This is Martin Fackler for the New York Times. I'm the Tokyo Bureau Chief. Japan suffered its largest earthquake on historical record today. An 8.8 magnitude earthquake hit off the northern coast. The quake itself did damage, but even more devastating was the tsunami that the quake unleashed. In some places, there were news reports of a wave more than 25 feet high that swept through entire towns, bulldozing through buildings and sweeping over cars as they were driving down a highway. The areas that were hit, many of them are very remote, and at this time it looks like there are at least 200, probably many more deaths, hundreds more missing. Entire swaths of northern Japan are now.
Hi, my name is Alhan Batra. I'm the Chief Financial and Science Officer at AERIS Drones, and I'm currently based in Tokyo, Japan. What still upsets me about that day was the fact that the majority of casualties were caused because rescue teams were either overwhelmed or could not access victims in time, things that could have easily been avoided with the right rescue methods. In 2024 alone, 393 disasters resulted in over 17,000 casualties worldwide. Yet despite the rising toll of natural disasters, search and rescue efforts remained largely outdated, still dependent on slow, manual methods of foraging through rubble with limited personnel. However, with rubble stretching in every direction and every second being valuable, identifying where victims are trapped becomes nearly impossible. In such conditions, conventional approaches are no longer just inefficient, they're ineffective. Therefore, we believe there's a critical need for a faster, more technological solution, one that can navigate debris, assess danger zones, and locate survivors with precision and speed. Introducing AERIS.
I'm Lucas Halverson, studying mechanical engineering with a focus on drone design.
I'm Daniel Lemetier, the Chief Systems Architect at AERIS Drones. I design and develop the integrations between the software, autonomous, and mechanical systems.
I'm Saket, a high school student interested in AI and machine learning. Our solution is an autonomous drone swarm, essentially a team of dedicated drones that launches within minutes of a disaster. Their mission is to be the first eye and ears of the scene, finding victims faster than ever before. Here's how it works. First, a large mapper drone acts as an eye in the sky. It uses laser mapping system called LiDAR, live 3D model of the scene for the rescue teams. While that's happening, our smaller drone flies into dangerous and hard-to-reach spaces using thermal cameras to search for the heat signature of survivors. But finding the person is just the first step. Our key innovation is figuring out if they're okay from a distance. The drone can use special cameras to detect tiny invisible changes in skin color caused by the person's pulse. From that, our AI can calculate their heart rate without any contact. We combine that with thermal data from the body temperature and even the radar that detects the subtle movements of their breathing. Ultimately, this transforms the entire response. Instead of searching blindly, rescue teams can get a live map and the exact location and signs of every survivor. We are turning hours of deadly uncertainty into minutes of life-saving actions. That's how we will change the survival rates.
Our technical roadmap combines cutting-edge technologies in an innovative way. We're designing a modular system. Mapper drones carry an array of LiDAR and thermal sensors for area mapping, while microscouts use button-sized cameras and CO2 sensors for victim detection. Our concept uses self-healing mesh networks with variable bandwidth signals built to survive infrastructure failure, critical when cell towers are down. We're developing mission profiles that auto-configure for different use cases: earthquake victim detection, wildfire evacuation routing, and flood rescue coordination. Each scenario optimizes sensor combinations and AI processing for maximum life-saving impact.
Our 5-year roadmap to SDG 11.5 starts with mentors and with the help of local businesses. In years 1 to 2, we aim to focus on building working prototypes of our design with engineering departments and validating computer algorithms of our solution alongside CS startups to enable our drone to fly autonomously. We have already begun this stage, with us having already secured venture capital from multiple funds and currently collaborating with leading drone companies to bring our vision to life. In years 3 to 4, we plan to partner with local emergency services for real-world testing. We aim to collaborate with leading emergency services such as the Association for Aid and Relief Japan and the American Red Cross Society. Insights from our trial runs with these organizations will allow us to refine and improve our solution before it's sold in the consumer market.
So, how do we know this will work? While we haven't done any physical tests yet, we have validated our concepts through detailed simulations and expert feedback. Our algorithms are hitting their performance targets in simulations, showing 95% accuracy in controlled tests. And we're getting crucial real-world design feedback from our engineering partners and the local fire department. This early work proves our idea isn't just a theory, it confirms our plan is achievable and designed for real-world constraints.
Considering costs of equipment, tools, and expert consultations, the design, advertising, and production of a single unit of our solution is estimated at around $10,000. Based on this, we propose an initial pricing of $12,250. This figure reflects various market considerations, including competitive pricing. According to 2024 industry reports, most specialized drone companies operate with around a 27% profit margin and price points above $15,000. To remain competitive, we have opted to reduce our initial margins. However, as we secure partnerships with external organizations, prices will gradually increase to ensure long-term viability. In parallel, we plan to allocate $2,000 toward R&D through a university grant and $5,000 for prototype development via government innovation funds.
We're not naive about the challenges. Regulatory approval requires working with national aviation authorities, weather resistance needs extensive testing, privacy concerns require strict data protection protocols. But every challenge has an engineering solution. That's why we're starting early, building partnerships and designing real-world constraints from day one. By 2030, we envision cities where disasters don't become humanitarian catastrophes.
Where every victim is found with the minutes, not hours, regardless of their neighborhood or income.
Where technology serves humanity's most fundamental need, survival and crisis.
Where resilient infrastructure means resilient communities for all.
This is our contribution to SDG 11.5, using innovation to significantly reduce disaster deaths and build truly disaster-resistant cities worldwide.
We're not just dreaming about the future, we're engineering it. Support our vision for AERIS.
Join us in making disaster-resilient cities a reality, because every life matters. Every second counts, and every city deserves protection. The future starts with an idea, and this is ours.